Now guys, every invention has some motive behind it. You don't just adapt anything without a reason, right? So to understand CI/CD from root level, we have to first understand why there was the need of CI/CD principles. Weren't the traditional SDLC standards not good enough to productionize your changes frequently? Were there any flaws in it? Any drawbacks in them? All of this we will discuss. To learn that, first let's discover how companies used to develop software projects conventionally before the adoption of CI/CD into their development culture. I'll break this lecture into two parts, where first we will see a high-level picture of what a software development cycle is, and then we will try to fit this cycle in an example. As a result of it, at the end of this section, you will be able to identify what were the missing aspects from the conventional SDLC methodologies that lead to the beginning of a new CI/CD work culture. Now guys, some of you may find these lectures to be of theoretical, and if you are already having the basic CI/CD knowledge and are here to only learn the GitLab specific part, then you can skip this section and jump on to the section from where the GitLab portion starts. Rest all can continue. Okay, so for any software application, whether it may be an e-commerce website, analytical application, mobile application or whatever, to produce a high quality software, the development teams have to do a lot of work for creating and maintaining that application. Application that meets or exceeds the customer expectations while remaining inside the time and cost limits. The term work here does not only refer to writing an optimized code for the application. Writing code is just one phase of software development. Along with that, there are a lot of other phases that any software has to go through to make it a high quality software. And all these phases in conjunct forms a complete software development lifecycle. So putting this term, software development lifecycle, in a formal way, software development lifecycle, acronym SDLC, is a systematic process used by software industry for building the high quality software that ensures to meet customer expectations with lowest time and cost as possible. This is the graphical picture of an SDLC process. SDLC consists of these phases or stages going through which a high quality software is produced as the end result. These phases include planning, defining, designing, building, testing, and finally deployment. Let me just briefly explain each development stage. Starting with the first phase, requirement gathering and analysis is the most important and crucial part of any software development lifecycle. At this stage, all the relevant information from the customers is collected as per their expectations. This step is performed by senior members of the team by taking inputs from the customer. Planning for the quality assurance requirements and identification of the risk associated with the projects is also done at this stage. After the requirements are clear and are planned, in the next phase, defining, all those product requirements are laid down onto a document or SRS, Software Requirement Specification document. This document is a formal document that consists of all the product requirements to be designed and developed during the project lifecycle. Then after defining, the next phase, designing, comes in. Now based on the requirements specified in the SRS document, in this stage, various design approaches to accomplish the product are architected and documented into a Design Document Specification (DDS). After design documents are created, they are compared and reviewed from all aspects like robustness, time, cost, and others, and the best approach is selected. Now that we have product requirements cleared, design document in hand, building is the stage where actual development of a software begins. This is where engineers will come in and start writing the code while sticking to the agreed blueprint. After the code is built, the generated code is tested against the requirements to make sure that the product is solving the needs gathered during the requirement stage, and it also meets the quality standards defined in the SRS document. Once the software testing phase is over and no bugs or errors are left in the system, then the final deployment process starts, where the software is formally released into the market. And once released, the maintenance of the product is taken care by the developers or some support team for any future errors or issues. Guys, once this cycle is completed, it's generally called an iteration. So after one successful iteration, the same cycle is followed again to release any new features or update the existing ones in the running software. So the cycle just goes and goes and goes. Alright, so these were few stages that every software development project follows for the generation of a high quality product. And yes, before we move to the next class, Guys, one thing worth mentioning here would be the stages that we just saw in SDLC are never conventional or modern. They remain the same. No matter what new standard or principles you adapt, these SDLC steps are going to be there forever. What really makes the difference is how the stages, preferably starting from development phase, are carried out internally. In short, if I have to say, in conventional models, these stages were carried out manually. That is, to carry any internal operation or to move the product from one phase to next phase in the life cycle, we need a person or set of teams. Like after the development, you will manually provide the code to testing team. Testing team would test the code manually, and then the final code is manually taken to production servers and all. A lot of manual activities are involved in the whole life cycle. But in modern models, with the adoption of continuous integration and continuous deployment culture, we try to fasten this transition from one phase to another by introducing automation within the underlying steps. And how exactly we automate it, you will see it in the coming lectures. So that's pretty much it for this lecture. See you next one.